At least if I make the meeting ID available, then I know people will find it. I'm under the impression that like you guys are supposed to like install the app, and then I guess maybe I need to re-add everyone to Teams or something. But I know that like at least if I post the meeting ID, I know that works. So I was like, okay, well that's not too difficult. I know the other time it kind of caused a hiccup because for some reason that day I could not log in. I was like, ugh. So we kind of got to the bottom of that. Okay, let me see this as far as updates. So I started the recording. It looks like everything is working properly. Let me see. Can I see my? Let's see if I can turn on here. Captions, right? Yeah. Um, Let me think. So I started to go ahead and do you guys' grades, but then I realized that we had assignments that were literally due like maybe 1 minute ago. So I was like, okay, well, let me just wait until after class to update grades. And when I go, more than likely I'll update grades over the next couple of days, and it'll be basically everything before chapter 7, excluding exam 1. I think exam 1 is, you should be able to access exam 1 now, and it's due next week, right? So when I go to update the grades, it'll be based on stuff. I think when I looked at it earlier, it was basically everything before chapter 7, excluding exam 1, right? So that'll be later. I just was trying to wait for the timing because I didn't want to pull the grades before things were due, and I knew something was due in like an hour or so. So I'll be updating that in a couple of days. Yeah. So today, we're just moving forward, right? I posted a bonus lecture. You guys don't really need it. I think it was section 3.8. I really only expect you guys to work on whatever's on my open math, right? So whatever assignments are there. I noticed that for like chapter 3, it may have stopped at maybe 3.5 or 3.6. So whatever's there, we're just gonna go with that. There are some bonus lectures where you don't really need those, so that's okay. When I was kind of glancing at the schedule, so this week I think it's really by the end of next week we need to have finished chapter 7, and then there's this chapter on matrices, right? So in chapter 7, it's just like 3 sections. So we're just going to kind of start on that today. I'm under the impression that we can kind of take our time. As long as we finish chapter 7 by the end of the week, we're okay. Okay. Let me see if there's anything else. I mentioned something about grades, and so we'll update that momentarily. And then yeah, we're just kind of moving, plugging and chugging and moving along. Yeah, I think we're okay. Like when I kind of checked things earlier, it looked like we were okay. There was something else I wanted to mention. This is like 30 slides here. Okay, so let's kind of just get it going. Oh, and I'll update attendance. You know, just that's the kind of stuff I'm working on over the next couple of days, like updating grades and attendance and things of that nature. Hopefully everyone is finding their way. If you are struggling or if you need support, you have to speak up. If you don't say anything, then it's a lot harder to help. But you have a lot of support, right? I do encourage you all to use my office hours, like to ask questions about homework. In an ideal world, we could work on homework during class, and usually I am able to do that. But this time it's a little bit different, just because this is my first run through for this material. So that's what's kind of throwing a wrench there. Yeah. So anyway, and there was something else. It'll come back later. Okay. So moving into chapter 7. So we're starting chapter 7 today. As long as we finish these next 3 sections by Thursday, we're good to go. So we don't have to rush. Let's see. So this chapter is over algebra with graphs, functions, and linear systems. So this is more like, traditional college algebra. And we're going to be starting with section 7.1, graphing and functions. Okay. A few objectives here. 1, we like to plot points in a rectangular coordinate system. 2, graph equations in a rectangular coordinate system. 3, use function notation. 4, graph functions. 5, use the vertical line test. 6, obtain information about a function from its graph. So points in ordered pairs. The horizontal number line is the x-axis and the vertical number line is the y-axis. The point of intersection of these axes is their 0 point called the origin. Let's see, negative numbers are shown to the left of and below the origin. The axis divides the plane into 4 quarters called the quadrant, right? So if you think about like a flat surface, and like typically when we're building the coordinate plane, we start with the x-axis, X-axis is just a horizontal line where the positive X direction goes off to the right. Let me do my little setup here. Right. Why you change? Why don't you just stay how I leave you? So positive X-axis goes off to the right. And then on top of the X-axis at a 90-degree angle, we lay the Y-axis where the positive Y goes up. And so then when we lay the horizontal X-axis on top of the vertical Y-axis, it breaks the flat surface up into 4 regions or 4 quadrants. And so we count the quadrants starting with the upper right. So the upper right, we call that the first quadrant. Greetings, everyone. Greetings. Anybody know why I don't say good morning? I try to go out of my way not to say good morning. Because, like, to me, like, morning is something that you do. Oh, no, her timing is not the best. She's going to have to wait. Oh, come on. I'm going to send her a voicemail. Okay, I think we're okay. It looks like everything is still going. Okay. Yeah, because mourning is something that you do when you're, like, lamenting or grieving the loss of something or someone. All right. So it always felt contradictory to say good morning. So that's why I'll be like either high vibrations or grand rising or something like that. Just something, to raise your vibration. But anyway, random stuff. Okay. So upper right is quadrant 1, right? And then it proceeds what? It proceeds counterclockwise. So everything in this direction is quadrant 1, right? Everything in this direction is quadrant 2. And then the lower left, all in this direction is quadrant 3. And then the bottom right is quadrant 4, right? So those number lines, they're too active right now. It's this one. I don't know how to. I don't. So I really think that, like, in order to get, that's why I started just posting the meeting ID. I don't know, and I have to pick one and start recording, and then the recording is there. So that's what gives me solace. Like, I know you're not missing it. You might get in the room late, but you get your credit. I can only see one, and I guess it isn't the right one. Let me see. Maybe if I go here, let me see if I go. How do I access that chat? Let's go here. Like this, chat. Let me just post it here. I can only see one. Let me just post it here. Paste. Come on. Do it. Okay, another place I have it is right here. Let's just copy this again. Copy. And paste. Yes. You can do it. You can do it. Come on. My device is like taking its sweet time. Let's cancel. Let's try this again. Paste. That's annoying. For whatever reason, it doesn't want to paste. And I think this is the right one. Because, yeah, we were kind of talking here. Paste. That's not working either. Let me try this again. Copy. Paste. There we go. Now it worked this time. Almost worked this time. Oh, this thing is so annoying. Okay, let's go here. Okay, another thing I can do, I think what I had to do last time, is paste it here and then copy this. It's like, it's acting trippy because, like, it's basically, anyway, I don't have time to explain it. But anyway, that's there. Okay, so I know that that's there. I at least got it there, and I think the other chat is good, so we're going to let that be. Okay. Yeah, so the x-axis with the y-axis breaks the flat surface up into 4 quadrants, where the crosshair, the center of the crosshair, the 0, 0 is called the origin. And then, and basically what this does is, like, we'll use this for, like, plotting points and looking at graphs and things of that nature. And so when we have our ordered pairs, our x comma y, what it is that does, it's kind of like directions or a roadmap to a certain point on the flat surface, right? So if we always start at the origin, and then when we have the ordered pairs, it's instructions on how to get to a certain specific location, and then we'll kind of explore a lot of different things there. Let me see. It looks good. Okay. So each point in the rectangular coordinate system corresponds to an ordered pair of real numbers, our x comma y. So look at the ordered pairs, right? So we have this -5, 3, and this 3, -5. So in order to graph those, right, we would start at the origin. -5, 3 means we go left on the x-axis 5 units and up 3 units in the positive y direction. We always start at the origin. The first coordinate is our x. If it's negative, we go left. Positive is right. And then the second coordinate is our y. If it's, oh, it's 11, 11. I'm gonna have to, I don't know. She's gonna have to wait. Hope she's okay. Then she's sending audio like that. That's even more challenging because I'm in the middle of this. Okay. I think I was here. Nope, not there. This one. There it is. Okay. All right. So I mean, I feel like plotting points is not too terribly bad. Again, the first coordinate is our x, and the second coordinate is our y. We always start at the origin, right? And that'll become second nature if it's not already second nature. I think I'm gonna just leave this one as an exercise. I'll just use my prepared notes. We're asked to plot these points. We have these ordered pairs. Okay. So like if we have, I'm just gonna use my prepared notes because it's not too difficult. All right. So for instance, A is -3, 5. So if we start at the origin, we go left 3, 1, 2, 3, and then a positive 5, 1, 2, 3, 4, 5, and you see A there. Okay. B is 2, -4. So 1, 2, 1, 2, 3, 4, and there's B. C is 5, 0. So that means go right 5, 1, 2, 3, 4, 5, and then we don't go up or down. So you see C there, so on and so on. All right. I feel like that's not too terribly bad. Okay. And as usual, if anything is not clear, feel free to unmute yourself to get my attention and we can talk about it, or type in the chat. I am monitoring the chat. But you know, yeah, let's keep it moving. So then we have graphs of equations. A relationship between two quantities can be expressed as an equation in two variables, such as y equals 4 minus x squared. A solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. The graph of an equation in two variables is a set of all points whose coordinates satisfy the equation. Nothing too difficult there. I'm just going to kind of let that be. Yeah. All right, so we're asked to graph this equation and then select integers for x starting with -3 and ending with 3. Okay. So we're going to graph this. I guess I'll go ahead and introduce some graph paper. Graph like this. Come on. Yeah, and I'll have to update attendance using. I have to go back into my logs and things of that nature. All right, so let's start with like a table. All right, let's go here. Okay. So I'm going to make my table, I guess we can do it vertical. We'll do x versus y. Okay. And we'll have x go like -3, -2, -1, 0, 1, 2, 3. So we just chose values of x, right? So we just chose some values of x. And then we're going to find the corresponding y. Okay. So then when x is -3, okay, I think I'm actually going to use my calculator just because I want to showcase it. Let's go. So I need to go like this. It's right here. That looks good. Let's reload and refresh. Okay. So I'm working on the TI 83 Plus. I mean, this one isn't too terribly bad to just plug in. I just wanted to showcase a feature. So if I go to my y equals and I put in 4 minus x squared, okay? So that's the function that we were given. And then basically what I want to do is plug in those different x values. Actually, the table is actually already created. So I was going to do each one individually. But if we look in the upper right-hand corner, it says graph. I'm going to click on second graph to access the table and go up. I'm going to start at -3. So then it's already done for us here. All right. Or if you did it manually, when you plug in -3 for x, -3 squared becomes a +9. 4 minus 9 is -5. Right? So this result would be -5. If we plugged in -2 for x, -2 times -2 is a +4. 4 minus 4 is 0. Right? Okay, if we plug in, and then, and so again, we already have it worked out here, so I'm just going to use this. 3, 4, see, 3, 4, 3. So 3, 4, 3, 0, -5. Okay. So we chose the values of x, we found the corresponding y's, and then we're going to plot the points. Notice that our x's go from -3 to 3. Our y's go from like -5 to 5. Is there somebody have a question? Okay.
Mr. Five,
Yes.
if we don't, are you going to show us how to use it if we don't have a calculator?
Okay, so I'll do a couple. So for instance, this first one, let me see, this is equal to 4 minus -3 squared, right? So then you do have to do order of operations, right? You have to know that, you do the exponent first, you get an answer, and then you say 4 minus that answer, right? So then it would be 4 minus 9, and that's where the -5 comes from. If we did this one, right? It's 4 minus 0 squared, right? So that's just, sorry, not 0. This is 4 minus what? -2 squared. So then we have to square the -2 first. So that's -2 times -2, which is a +4. So then that ends up being 4 minus 4. Right? I'll do one more. So this one is going to be 4 minus x squared, but the x in this case is -1. So -1 times +1. So then that ends up being 4 minus 1, and we get the 3. Oh, she had a short break. Yeah. Okay. I think we got enough space. Let me see. I'm going to put my origin about here. Okay. On the x-axis, we just need to cover the 3's. Go ahead.
No, I get it. Thank you.
Yeah. Okay. Oh no. And then the y's, we need to go like cover the 5's, right? So I think we can go like this, and we should have enough. Okay. Let me do like this. Okay. So on the x-axis, we can go 1, 2, 3, 4. 1, 2, 3. That's enough. We have an origin here, and then we need to get to 5 there. Let me see. 1, 2, 3. That's not enough. 2, 4, 6. Yeah, let's go 2, 4, 6. That'll be good there. 2, 4, 6. Okay. And so we need to label our axes. Here we went 1, 2, 3, 4, 2, 3, and on the left, these are our negatives. Vertically, we went by 2, so we could say 2, 4, 6, 2, 4, 6, and on the bottom half, we have our negatives. Okay. Again, to the right is our positive x. Vertically up is our positive y. So if we plot these ordered pairs, -3, -5, and actually, go paper. Oh, that's not an option anymore. Oh, there it is. Okay. Yes. For some reason, it's easier for me to graph like the dots. Like I can see it easier, better. But you know, it's the same as with graph paper. -3, oh, -5 is here. Okay. This is -3, -5. Then we got -2, 0. So -2, 0 is here. And I'm just labeling my points. It just kind of helps. -1, 3. So -1, 3 is here. Okay. 0, 4 is here. One, 3 over 1 and up 3 is here. Okay. 2, 0 is here. And 3, -5 is here. Oops, do -5. Yeah. Okay, let me see. How do I get to the other chat? I wish I had clicked on that. I'll get there. Get rid of this. It's not that one. This one. Let me paste and send. Okay, that should work. All right, cool. Cool. Okay, so then now that we've plotted our points, we just connect them with a smooth curve. As smooth the curve as we can draw, right? So we're just gonna go like this. Smooth criminal. It wasn't too bad. That was pretty good, right? Okay, let's go paper and let's turn off these support, right? Okay, that was us doing it by hand. And then in the graphing calculator, let's go to window and let's set it to the same window, right? So we went by 3. So the x minimum, let's do -4. X max, let's do 4. X scale can go by 1 is fine. The y minimum, let's go down to like 8. And let's go up to 6. And we can go by 2's on the y-axis. Okay. And so here's a computer generated graph that matches what we did by hand. Okay. So this technology, I mean, with all its abilities, it's really just an extension of our natural abilities. The only reason that we may or may not be able to do things is because, you know, it depends on what we nurture and cultivate. But all the things that the calculator can do, we can actually do. We can do it, and we can actually do it better and faster. We just don't know it. Like, for instance, when I was a student in college, you know, one of my professors, he did a showcase where he was able to crunch numbers faster than the calculator. We would spit out like, you know, 3-digit numbers like 5547 times 236, and he could spit out the answer faster than we can put it in the calculator. Right? I mean, it's like that was just one of the showcases that he did. I think that comes out of like number theory. It's just, again, this technology is just an extension of our natural abilities. It's just that, you know, these smart devices kind of make us lazy and dumb, right? Because we don't use our minds the way they could be used, right? So then we lose these abilities. But if we actually practice, and not that it's like anything, but it's just like, okay, if we can outperform these devices like in crunching numbers, well, what else can we do? What else can we outperform? Or what else, like what are the capabilities or the limits of the human capacity, right? But the average person doesn't really think like that. But again, all this stuff came because somebody at some point in time stopped and actually thought like that. Like they sat and thought and like, okay, well, is there a way we can automate this process? Can we do it faster? What are the limits? How do we make it more efficient? You know, but it's hard to sit and ask those kind of questions if we're worried about the day to day, if we're worried about, okay, paying bills. Like, I still don't believe in paying bills because I'm like, we're the only species that pays bills. Nobody else pays bills. It's just us. We somehow as a collective agree to pay bills as opposed to let's just make sure that everybody has what they need, you know? And then we can automate. We have technology where we can automate processes. Like, why are we still tripping about work? If these robots are going to come and like take our jobs, then that means we shouldn't have to pay bills either. You can't like reduce our pay, but then still expect us to pay for rent and stuff like that. That's bogus. That's malarkey. So I always try to encourage people to I really enjoy like 3D printers. I've seen where this guy had a client when I was driving for Uber. He says he had like a 3D printer and he would just make his own phone cases. I was like, yeah, because I be knowing exactly what I'm looking for in my phone case. Like, and they always changing the design to try to, they're clearly like cahoots. Like when they come up with a new device, it's the exact same device, but they'll change something minor so you get a new case and you have to buy new things. And so, but if you could just make it yourself, you free yourself. Like we don't really need these companies and institutions. We just need to be left alone and we can build it ourselves. We can build it ourselves and do better. Like, we don't need this stuff that breaks down. Like, for instance, light bulbs are not supposed to burn out. There is a light bulb that's been burning for like 50 odd years, and the light bulb company was like, oh, that bulb is defective. Like, no, that's bogus. The bulbs you produce regularly are defective. You intentionally make those bulbs to burn out and to have wear and tear. Imagine a battery that can like charge your device in like 3 seconds instead of 3 hours. Imagine, a car, I don't know, that can pull electricity out of thin air. Then if you had a vehicle that can pull electricity out of thin air and charge, you never have to like do anything to charge it. You never have to pay for gas. Then what are the limits of what you can do? How far could you go? Does it work in space? How far in space can you get past the Van Allen belt? Like, it's these kind of questions. Like, it gets into some really kooky stuff when you start to stop worrying about the mundane and stop worrying about the day to day. But I really feel like with all the calamity that's going on, we're on the precipice or on the verge of a golden age. Like, we're primed to be a golden age. We just kind of got to grow up collectively. We got to stop being childish, stop being immature, stop being spreading hate and stuff like that. And like, but we really could make this a utopia for real. Like, we're right there. We're so close. We just got to grow up just a little bit. And it's not even everybody. You just need enough people to be on that mindset, and then it'll kind of like cascade. It'll like it's called the critical value or critical limit or something like that. Anyway, don't get me started because I can go on those tangents and rabbit holes. So okay, so I think this is just a type version of what we just experienced. So, again, we chose the values of x. We passed each of those x values through our function to generate the corresponding y. We generated a set of ordered pairs. We plotted the ordered pairs, and I think we got the same image. We did it by hand. We saw it in a graphing calculator. If you don't have a graphing calculator, you can also, I know a lot of my students like to use, you can use one of the following two websites for free virtual graphing. It just takes a little bit of like research on how to use it. But I know a lot of students like to use what's called Desmos.com. That's like a free virtual calculator. And the one that was introduced to me originally is called Algebra.com. These are free graphing utilities. All right, so that's what these are. Yeah, and I really feel like with all the calamity that's about to ensue, on our end, we just need to do our best to survive. Like, if we can just get through, like, if we can get through maybe 2030, I think on the backside of that is a real golden age, not this pseudo do what I say or else I'm going to ostracize you and starve you out. No, like an actual true golden age. It's like people are getting fed up, and we're clearly in the age of Aquarius, where this is the information age. So it's like all these like hidden agendas and lies and deceit and all that, it don't work no more because information is readily available. It's like something happens and everybody worldwide knows, like instantly, So it's harder for that nefarious stuff to work because they can't hide. You can't hide behind lies anymore. Like, it's actually starting to fall. So anyway, back over here, we have functions, right? So if an equation in two variables, x and y, yields precisely one value of y for each value of x, we say that y is a function of x, all right? Let me see. So in order to, like, the way I identify something as a function, basically it has to pass the vertical line test. That means that We don't, or in other words, every y corresponds to exactly one x. You don't, or in other words, every x corresponds to exactly one y. You don't have one x corresponding to more than one y. If you had one x value that corresponds to more than one y value, that's an example of something that's going to fail the vertical line test. It's like you have points stacked on top of each other. So functions pass the vertical line test. That means that no matter where you draw a vertical line, it only touches the graph once. If you can draw a vertical line in an image and it touches the graph more than once, then it's not a function. All right. So every x corresponds to exactly one y. The notation y equals f of x indicates that the variable y is a function of x. The notation f of x is read f of x. All right. So a common error with this notation that students sometimes do, sometimes students will multiply by an x. That's not what's going on. We're not saying f times x. This is not multiplication. This is the function f evaluated at the value of x, right? That's what this means. Okay, just a moment. I'm gonna check something real quick. Cool beans. Let me click on, where is it? Let me stop this. Oh, okay. I think I will do both. That's for the sake of doing it. One, nice, and two. Oh, good God. All right. We are ready to rock and roll. Okay. Where did, there it is. Okay, cool. Oh, so I think we have most people here. I'll say this. So I feel like to reduce or to minimize like the confusion as far as the rooms, I'm under the impression that, you know, basically the way you log into the class is like you install the Teams app. I might need to like re-invite everybody, and like once you install the app, you'll see the calendar where I've scheduled. I usually just click on the calendar, so I go into the room for that day. But it's supposed to be the same room, and so but also what I've been doing as of late, it seems like it's been working, is just posting the meeting ID. Don't do a link, just do the meeting ID, and it does seem like it changes, and I don't know how to make it not change. So either you have one or two options, like either install the Teams app. You should be able to see it on the calendar, and then just use that, or you'd have to wait for me to like post the meeting ID with the login information at each session. We'll get that done. But so far, it seems like it's okay, and it seems like we've gotten to the bottom of what's going on. Okay, let's keep it going. So an example, an application involving function notation. Tailgaters beware. If your car is going 35 miles per hour on dry pavement, your required stopping distance is 160 feet, or the width of a football field. At 65 miles per hour, the distance required is 410 feet, or approximately the length of 1 1/10 football field. Figure A on the next slide shows stopping distances for cars at various speeds on dry roads and on wet roads. Figure B on the next slide uses a line graph to represent stopping distances at various speeds on dry roads. Let's look at it. Stopping distances for cars at selected speeds on dry pavement versus wet. So notice that when it's wet, you need a larger stopping distance. Now this is what, 35, 45, 55, and 65. So now in my mind, I'm like, well, can we verify these results? What would it take to verify? Now I'm getting images of like, I don't know if y'all know this old series called Mythbusters, but like I could see like, okay, we got a stunt car, we have like this pavement, and we hit a constant speed of 35, and then when we hit the line, we slam on the brakes, and we see, how quickly can we stop, right? Obviously we don't have these tools, but it's just fun to like, that's when like the mathematics and the science comes to life. I mean, like Mythbusters used to be one of my favorite series because it was they took science, like the stuff we're talking about, and they used it to test like, just what are those things called? Like, I keep wanting to say theories and myths, just like different things that people would believe. Like, okay, like the 5-second rule, if you drop something on the ground, if you pick it up within 5 seconds, is it safe to eat? And so to test that, you would have a control where something doesn't touch the ground, you would swab it and do a bacteria culture. Then you would drop something maybe dry, pick it up within like 3 seconds or something like that. Do a swab and create a bacteria culture, do something exactly 5 seconds, and do something maybe for 7 seconds, 10 seconds, 15 seconds. You do it dry, and then you also do the same thing with something like wet, like a slice of bologna, and do a bacteria culture, something like that. And so, they would just test little stuff like that Another one was like the curved bullets from like Wanted. It was just like random stuff, but it was so much fun because it was science. It was like true science. Like, okay, what are we trying? What's our hypothesis? What are we trying to explore? And they're using this kind of stuff, charts and graphs and data. Um, Whatever you measure grows. Like if you want to be precise or accurate or efficient, you got to measure it, and you need stuff like this, right? So that's how a lot of stuff is done with this kind of discussion. Okay. Anywho, that's neither here nor there. Stopping distances for cars on drive pavement. So they made a line graph for specifically drive pavement, 20 miles per hour, the stopping distance. They had these several points, and then they kind of created a polygraph, like little segments or whatever. Okay. So then it says use the line graph to estimate a car's required stopping distance at 60 miles per hour on drive pavement, and they round to the nearest 10 feet. Use the line graph at 60 miles per hour to estimate. Okay, what is that? Like about 350 or 360, slightly above halfway, maybe 360 feet. Just as 60 feet is here, so then the corresponding y is slightly above halfway. Okay, I will go 360. Okay, let's see on the next slide. So the required stopping distance at 60 miles per hour is estimated using the point shown below, approximately 360 feet. The second corner of the point extends slightly more than midway between 300 and 400 on the vertical axis. Thus, 360 is a reasonable estimate. We conclude that at 60 miles per hour on dry pavement, the required stopping distance is approximately 360 feet. Okay, another random story. Once upon a time, I had a little crotch rocket, right? A motorcycle, the Kawasaki Ninja 500. Thing was fun, right? But obviously it's a motorcycle, so it's like it's only two wheels, so you have less surface area. So that means when you go to stop, you have to give yourself even more distance to stop, right? So you had to give yourself plenty of stopping distance. So I usually would try not to follow too close behind cars, and if I was behind the car, I always tried to have my like an exit route, either left or right, ready to go. And so oftentimes what would happen is I would be out and then I would get caught in the rain. Now, when you're out in the rain walking, it's fine. It's a little bit annoying because everything is wet. But like on the motorcycle, when it rains, oh my goodness, it feels like little like rocks are hitting you, like all over your body. You're like, crap, this hurts, right? And so I remember once I'm going up 75, and I think I was getting off on like 10th Street, and it started raining and it was coming down kind of hard. And so 75, I might be going maybe 60 or 65 miles per hour on a motorcycle. And then when I go to exit, when you're on a motorcycle, it's a lot going on. Each one of your limbs is doing something. Obviously your head is like looking at traffic and stuff like that. Your left hand is a clutch, your right hand is like the front brake, your left foot is the gear shift, and your right foot is the rear brake, right? So each one of your limbs is like doing something between the clutch and shifting gears and front and back brakes. And then you're watching traffic. It's a lot that goes on. So I'm trying to get over to get to my exit. And when I get into my lane, traffic just stops. I was going 60. I was like, fuck. So I slam on my brakes, front and rear, just both of them. And I start fishtailing like sideways, like something out of the Matrix. Like I was like, yo, and I'm about to hit this car. I was like, okay, I can't keep doing this. So I pump the brakes so the motorcycle straightens up. And instead of trying to stop, I like do this like swerve to go around, get out of the lane and go past the cars. So then when I swerve, I don't stop until about 3 or 4 car lengths. Like if I had stayed in that lane, I would have like smashed into those cars. But I was able to dodge, and even though I stopped like 3 or 4 car lengths ahead, I was able to like not to avoid. I was able to avoid a collision. So no moral of the story. It's just a story. But I will. There was another one though. Now if I were to dig into my files, I could probably find this video. So because I do like rideshare, I'm an Uber driver and stuff like that. I decided to get like a dash cam. Man, I be catching all sorts of stuff in my dash cam from just fires. Like there was a stretch. I saw like 3 fires in the matter of like two weeks or something like that. So once I'm sitting at this light, waiting for the light to change or whatever. And to the right, there's a right-hand turning lane, but it's a long lane. It's about 12 cars long for the right lane to turn right. So whenever you're like using that right-hand lane to pass cars, you got to be careful of somebody turning left and cutting across. And sure enough, This motorcycle comes zooming down the right hand side. I was like, oh crap. And this truck is making a left, and truck sticks out. And because the motorcycle's going fast along the cars, they just did not see each other. I caught it on video on my dash cam. It was kind of in the corner, but you could see him zoom by, and he just went flying over that truck. Like it was basically like this wall appeared, and so I pull over to go help him, and a lot of people get out to help him. One lady's like, "Guys, back up! I'm a nurse. I actually do this for a living." And she was like, she had to hold him down. His bones were sticking out. There's blood everywhere. Like, yeah. Again, no moral of the story. Just be careful when you're out there, right? But stopping distance. It was this. Like he didn't have that sense to be like, okay, let me not zoom down the side of these cars in case somebody's turning left, because you got to give yourself space to stop. He needed stopping distance, and because he didn't give himself stopping distance, it was nearly unavoidable. The only way he could avoid is if he was just going slow, and he kind of had some forethought to think, well, let me be careful because in case somebody's turning left, and nobody could see it, because he's going fast down the side. The guy's turning left. We're in like bumper to bumper, so he's trying to peek out to see around the cars, and it was just, and it was weird. He was out of it. He was like, the nurse was like, "Do you have any children?" I think he said like either two girls or a boy and a girl, and she was like, "Do you know where you are?" And he did not know like where he was. So I mean, we kind of helped him until the ambulance came, and then we kind of went on. But it was this kind of thing, stopping distance. Not that you would do these calculations. It's just a matter of being aware. The faster you go, you need more distance between you and the car in front of you. So that's enough for story time. Is that it? Okay, there we go. Let me see what else. How many more we got? Okay, we're good. So as long as we finish this section by today, I think we'll be okay. Let me see. I think we're good on the last one. So this function models of cars require stopping distance in feet on dry pavement traveling at X miles per hour. Use this function to find the required stopping distance at 60 miles per hour, round to the nearest foot. So something like this, I would just use a calculator. That does take practice in being able to type this in the calculator. Not all calculators are created equal. So it is a good idea for you to have like whichever calculator you intend on using and practice with that. I'm just going to showcase how I do this in this one, the TI-83 Plus. Okay. And I'm a fan of something like this. I would rather just go to my y equals and put it in there. So I can do 0.0875, come on, x squared minus 0.4 x plus 66.6. Okay. So then what I'm going to do, I'm going to call in that function I just typed in. So on the right-hand side of the calculator, there's a button that says clear. Left of that is a button that says VARS. I think it's short for variables. I'm going to click on that button. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function, and then number 1 again to call the function I just typed in. And I want to evaluate this function when X is 60. And it says to the nearest foot. So the nearest foot would be approximately 358. So, but again, something like this, you would just put it in the calculator. Approximately 358, okay? 358 feet. You see it here. Okay. All right, let's keep it moving. So we're asked to graph F and graph G in the same rectangular coordinate system, and then select integers for X from -2 to 2 inclusive. Okay. So we're going to make a table, and we want to graph F and G in the same coordinate plane. Okay. So let me introduce some graph paper. Let's do some space. Paper, grid paper like this. Nice. Okay. Let's see. Okay. Uh-oh. What happened? Oh no. Oh, okay. I think I just clicked. Okay. So we're making a table. So we can say like, let's go here. We got our X. And then we're saying f and g. So if that's x, we're going to do our f of x, and we'll do our g of x. Okay. And so it says, like, we're going to choose values as x goes from -2 to 2. So we'll go something like, we can do like this. Okay. And let's go like this. So then we'll let x be, let me see, -2, -1, 0, 1, 2. All right, I think that's enough there. So now, when x is -2, for f, let me see, let's go like this. That's going to be a -4, -2, 0, 2, and 4. And then when x is -2, we're going to plug it into g. So it looks like we just basically add 4 to those results. So we're going to get 0, 2, 4, 6, and 8. Okay. Yeah, this life is short. Yeah. I just lost my cousin literally yesterday morning in like a bizarre thing. Like, I guess she woke up and she couldn't breathe. She called her husband. She was able to like scream out to him, and then that was it. So I just say that to say, life is precious. So just, if there's something that you want to do or you can do, if you can do it and you want to do it, I would encourage you to do it. Because I mean, and she left behind like 3 little girls. Like, he's a pastor of a church. I'm just like, jeez. So now we're like, trying to make plans to, and she's like the same age as me. So that's the thing that's just, it's just trippy. It's just, everything is, I feel like everything is so precious. No moment is guaranteed. So it's like, seize the day. Like, there's no need to delay. It makes me think of like an ex of mine, her mom and her grandma. They were like afraid of everything. So they stayed inside all the time. Like, they would not leave. They would only leave to like go get groceries. And I guess they fell asleep. It sounded like somebody fell asleep smoking in the bed, and then the cigarette, I guess, fell and the bed caught fire. Whole house burned down. And the only person that did not make it out was the grandma. But it's like, so for me, it's kind of trippy because it's like, it is scary facing your mortality, but no human makes it out of here alive, right? So you have to face it sooner or later. You just have to accept it. And so then it's like, but there's no point in living in fear, because it's not like you can do anything about it. Like, that fear, you can't do anything about it. You just have to accept it. And so like, then I started thinking about like Deepak Chopra, and he'll say things like, there's an aspect of every human that, like, water cannot wet, fire cannot burn, weapons cannot cleave. It's timeless, it's eternal, it always has been, and it always will be. There's an aspect of us that's like this that spark, right? And so he was like, when you start to identify with that aspect of yourself, you start to abandon your fear of the body, because your fear of death, because you know that, okay, you're either going to go to heaven or hell, or you might come back here, but you know that you keep going. You know that this body is just your vehicle to interact with stuff on this plane, but this is not who you are, right? Don't get me started on all that, because then you start getting into like, okay, you know, all the stuff, all the science and research has been done on like consciousness and stuff like that. He's like a neurosurgeon that studies consciousness, like, but he mixes like Western, like medical studies with Eastern philosophy of religion. Like, he mixes like, science with spirituality. So it's really interesting, like the stuff that he talks about. I haven't listened to him in a while, but there was a good stretch of my life where that's who I would listen to like a lot. Just because he talked about spirituality from a scientific standpoint. He showed studies that supported in all these interesting cases. Like this one kid that went into a coma, just a regular kid like us, like American or whatever. And then when he came out of the coma, he only spoke fluent French. He'd never studied any French. He had never, Like how do you explain stuff like that? How do you explain something like that? So he studies consciousness. He tries to get to the root of what is consciousness. Like how do you explain people that claim to remember their past lives, like children, and they'll say like random names, and then when the parents go to research it, it turns out the person was accurate, and they dig up bones and they show that this person was actually the murderer. And here's the body, there's the weapon. They did it on this date, and when they check what the person was saying, it's actually true. How do you explain stuff like that, right? Other than we're not these bodies, like we're just using these bodies to have experiences. Don't get me started on that stuff too, because I'll go in. We got a solid 25 minutes, so and we're actually almost done with this section, so we're actually okay. I don't mind telling stories. Like, I know my stories are probably bad, but I don't know. I enjoy them, so that's enough for me. It's enough for me. So let me see. Our x's go from -2 to 2. Our y's, we go down to like -5 and up to maybe like 10. Okay, I think we can do that. Let me see there. And okay, so let's put the origin. Let's put the origin about like here. Should be good. Okay. We'll let positive y go in this direction. I'm gonna have to look up some Deepak Chopra though, because I just it's been a minute. I used to listen to him and like Oprah, but now Oprah is like she got this like weird air about her now. It's like I keep seeing things about just weird stuff with Oprah. So it's like I don't know. I think that's probably what happened because Deepak Chopra and Oprah used to be. That was actually a running joke. They were like, I think Deepak Chopra. I actually got to meet him once as well. That ex, she got me some tickets. The ex I was telling you about, she got me some tickets to see Deepak Chopra. So that was like a bucket list thing. That was really cool. But Deepak Chopra made this joke. He was like, Oprah, I can't do the accent. It's been so long. He was like, if we got married, your name would be Oprah Chopra. It's just really funny. So that's neither here nor there. Okay. So now we're plotting this F and this G, right? So if we focus on F, the first order pair, let's do F. Let's do F and I call this like fuchsia. Let's do, come on. Let me see. I want these guys and I also want this. And then that's it. I want those to be, oh no. Style. I want those to be this color. Oh no, that did not work. Why did it do that? Let's try that again. That did not work the way I thought it was going to work. Okay. Let me see. Can I just go like this? Style. Okay, that's better. And then I'll just change this by itself. Style is black. Oh no. You were tripping. We're almost there. Come on, don't do me like this. Let's try it over here. Style black. There we go. Okay, and then we'll do G in green. All right, when I see G, I think green. Style, like this color green. That looks good. And then we just want this guy to be black. There we go. Okay. All right. So I think that's fuchsia, right? It's like a hot pink. So when X is, oh, we need to do our labels. Let me see. If we just need 2, we can go 1, 2, 3. That's good. 1, 2, 3. That's good like that. This is the positive X in this direction. Y's, we need to get down to at least like about 5. Let's see. 2, 4, 6. Okay, that's fine. So we'll go 2, 4. And this is our origin. We need to get up to like about 10, 2, 4, 6. I think 8 is good. Okay. These went by 1s, 2, 3. 1, 2, 3, 4. These went by 2s. These are negative. 2, 4, 6, 8. 2, 4. Negatives. Okay. All right. So I think we're ready to graph now. And I actually like, let's go paper. I like to graph on the dots. It's just easier for me. Okay. So when X is -2, the corresponding Y is -4. Here it is right here. We'll just go with that. This is -2, -4. -1, -2 is here. Okay. I guess the origin is like it passes through the origin. Just being a little bit OCD. Style, feel, that color. It's decent. Okay. This, that, and delete. Copy. All right. So we said -2, -4 is there. No. What's going on? This one. Yeah. Paste. There we go. -1, -2 is here. Paste. Then we have the origin. 1, 2. Paste. So over 1 and up 2 is here. And then 2, 4. Let's paste. Over 2 and up 4 is here. Okay. So then what we can do is connect those with the straight edge. So it's like going from here, here. Okay. And so that's the graph of F. Oh, and this is our positive Y in this direction. And then the graph of G. Can we just copy and paste that? Let's, I mean, I could. Let me just do it individually. And let's go style, this color, style, stroke is this color. Okay. And let's copy. Okay. Nope, undo. Okay. So when X is -2, Y is 0. Okay, paste. -1, 2 is here. Paste. 0, 4. Here. 1, 6 is here. And then 2, 8. Like this kind of stuff is like therapeutic to me. Like I actually enjoy it. It's like I do origami. I used to draw and sculpt and do all this stuff, and I do intend to start this stuff soon. I'm gonna just copy, paste, and I'll change the color. Style is this one, and let's try that again. Yeah, okay, that looks good. Okay, what's the time? We got. Let's hang out for 10 more minutes, and then I'll let you go. It wouldn't hurt. Let me just go ahead and do these labels. So this was -2, 0. This was -1, 2. This was 0, 4. This is 1, 6. Right about 1, 6 is there. And 2, 8. 2, 8. Okay. All right. That was an adventure. Let me try to finish out this section at least, right? So we grabbed F and G on the same coordinate plane. Let me get rid of these dots, right? I think this looks good. We did it by hand, right? We're gonna let that be. So here's the prepared notes, right? They found the order pairs with F. They found the order pairs with G, and then they plotted the two on the. What do we notice, right? The two graphs are. This is called two lines that are parallel, they'll have the same slope with different y-intercepts. The same slope with different y-intercepts. Okay. So then the vertical line test for functions. So this is what I was describing earlier when we're looking at a graph and we want to determine if it's a function or not. This is where we have the vertical line test for functions. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So what they're saying is if we can draw a vertical line and it touches the graph more than once, then it's not a function. Okay. So use the vertical line test to identify graphs in which y is a function of x. For instance, A, is that a function? We would say no, because we can draw a vertical line and it touches it more than once. So A is not a function. B is a function because no matter where we draw a vertical line, it only touches the graph once. C is a function, and then D is not a function because we can draw a vertical line and it touches it more than once, right? So we got no, yes, yes, no. Let's see. Not a function, 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 not a function. Okay. So hopefully that made sense. We're almost there. The given graph illustrates the body temperature from 8 a.m. to 3 p.m. Let x be the number of hours after 8 a.m. and let y be the body temperature at time x. What is the temperature at 8 a.m.? During which period of the time is your temperature decreasing? Estimate your minimum temperature during the time period shown. How many hours after 8 a.m. does this occur? At what time does this occur? Let's go back and answer the question. So for part A, it says, what is the temperature at 8 a.m.? Hours after 8 a.m., the temperature at 8 a.m. So if we're saying, if we want 0 hours after 8 a.m., then I guess that's when x is 0, the temperature is what, 101 degrees Fahrenheit? Is it body temperature? This must be body temperature, right? Okay. So 8 a.m., we got 101 degrees Fahrenheit. Let's see part A. Oh, we got more questions. Yeah, 101 degrees is correct. Okay. Part B, during which period of time is your temperature decreasing? Our temperature is decreasing from 8 a.m. to 3 hours later. So what is it? 8 a.m. to 11 a.m. So B should be 8 a.m. to 11 a.m. 8 a.m. and 11 a.m. is correct. C, estimate your minimum temperature during the time period shown. The minimum is a little bit above halfway between 98 and 99. So we could say approximately 98.6. How many hours after 8 a.m. does this occur? 3 hours after 8 a.m. What time does this occur? 11 a.m. So our estimate for the minimum temperature is 98.6 degrees Fahrenheit, 3 hours after 8 a.m., which is 11 a.m. So let's see, it's C. We got 98.6. 98.6 looks good at 11 a.m. Okay. D, during which period of time is your temperature increasing? Our temperature is increasing from 3 hours after 8 up until 5 hours after 8. So that's what? 11 a.m. to 1 p.m. So D should be 11 a.m. to 1 p.m. That's correct. E, part of the graph is shown as a horizontal line. What does this mean about our temperature and when does this occur? That means our temperature is what? Steady 5 hours after 8 a.m. So 4 would be noon. So that puts us at what, like 1 o'clock? So from 1 o'clock on, our temperature is steady. Maybe we were like running a fever or something, and it had to come down and then readjust. So the horizontal line segment shown indicates that the temperature is neither increasing nor decreasing. So that's a steady temperature between 5 to 7. Thus, the temperature is constant. I forgot to get the temperature, 100 degrees Fahrenheit between 1 p.m. and 3 p.m. By the vertical line test, we can see that no vertical line will intersect the graph more than once. So the body temperature is a function of time. Each hour represents, we didn't see F yet. So then F, explain why the graph defines y as a function of x. In other words, because it passes the vertical line test. Every x corresponds to exactly one y. We don't have one x corresponding to multiple y's. Okay, and then the typed up explanation, again, by the vertical line test, we see that no vertical line will intersect the graph more than once. So the body temperature is a function of time. Each hour represents one body temperature. Okay. Okay. All right, so we at least got through, what is this, 7.1? So idealistically, we can get through 7.3 on Thursday. I know we still need to do 7.2 and 7.3. More than likely, I'm still going to take my time, and I'll just have to commit that if we don't finish 7.3 by the end of next lecture, then I'm going to have to, maybe I might just stay after class on Thursday until I finish, right? So I'll let you guys go on time on Thursday, but then if I don't finish, I'll just try to keep streaming to finish out 7.3. Okay. Are there any questions? Are there any questions? Okay, just as a quick recap. So I'll be updating our grades, the grade book, over the next couple of days. When I looked at it earlier, it's basically everything before chapter 7, excluding exam 3, because exam 3 isn't due until next week. But before that, it's going to be there. So once I do update the grades, you just want to check it for accuracy. If anything looks out of order, just bring it to my attention, and we can try to get to the bottom of it. I'll be updating attendance, and this week we really just need to get through chapter 7. That's my impression. Okay. If there aren't any burning questions, we're going to go ahead and end this session here. And from one beautiful mind to another, enjoy the rest of your day. See you all Thursday, same time, same place. Take care. Peace. I think exam 1 is due next week. I think that's what I saw. So I think you have time. I mean, if you're going to submit it, it's fine. But I won't pull that grade until next week, until after it's due, because I need to honor the due date. Yep. Exam 1 is due today. You sure about that? Let me see. I think it's next week. I thought it said the 19th. Let me look at it. I mean, if it is due, then I did it based on the due date. Let me just check. Hang on. I need this to go away. Done. Let's just open up another one. My Open Math. Let's log in. That looks good. This course. Oh, not exam 1. Yeah, it's exam 1, right? Yeah, it says the 19th. It says due Tuesday, the 19th at 11. Oh, yeah.
Okay. I also have a quick question. So with the union and the intersection stuff, the exponent letter C, is that like next to, like, say if it's next to A, would that mean it's excluding, like?
Do you have? Is that like from the homework or quiz or something? Do you have that? Can you like screenshot that and send it to me? And like I can pull it up and we can talk about it.
Okay, I gotta figure out how to screenshot again. Okay.
What kind of device are you working on?
On the Mac.
MacBook Pro, I think, is Command. It's like Shift, and then it's either 3 and or 4. Or yeah, it's like Command Shift 3 or Command Shift 4, something like that.
Okay, I'm about to send it to you.
Okay. Just let me know once you sent it, and I'll pull it up. And so essentially, guys, like, yeah, go ahead.
I did some makeover, but it's not graded yet.
What sections?
1 second.
I sent it.
Okay. If your makeup work is basically anything before chapter 7, it'll be updated. Because
Okay.
I'm gonna update grades in like a couple of days, in like the next couple of days.
Okay,
Let me
it is.
yeah. Let me see. This is this one. You put it on the bulletin? No. Where did you send it? Did you do it in like Teams or something?
Are you talking to me?
No.
Yeah.
I'm not sure. You said you sent to who? Who was that a moment ago? You still there? Uh-oh. I don't see it. Let me see. I see a comment on the bulletin board. Let me check Teams. Oh, let's go back. Get rid of this. Who was that was speaking a moment ago? Was that Naomi? Let's get rid of this. Okay, I see it now. Yeah, that wasn't even okay. Miss McDowell, are you there?
Yeah, sorry.
Let me see. Score question 13. Can I just copy this? Let me share. I guess I can just screenshot.
Because I forgot what chapter that was in. I think it was chapter 2, I think.
Yeah, well, we can talk about it. Just give me a moment. I'm just pulling it up. This is what, question 13?
Mm-hmm.
Copy. Okay, let me add a page. Or actually, let me go here. Can I just copy? I shouldn't have done that. I might have to redo this again. Yeah, okay, let's do this. So let's go here. Paste. And then I'm glad I didn't close this. Let's copy this. And you can do it. I believe in you. Here, I think if I go like this, paste. Oh, you pasted the wrong thing. Let's delete. Share. If I just airdrop, that'll work too. There we go. We're gonna hop here. And come on. This one. This one. Yeah, cancel. Okay, cool. Okay. So let's see. We had this question. There we go. It's like, it's just throwing attention. Okay. So it says, you should be able to see my screen. Get done. You can save it. That's fine. Let's be the universal set, okay, where it's basically the positive counting numbers from 1 to 20. Let sets A and B be subsets of S, where A are going to be these numbers, B are going to be these numbers. Find the following, the number of elements in the sets, okay, A intersection B complement, all right? So if we're trying to find A intersection B complement, maybe we should find B complement first. Does that make sense? So B complement is going to be everything that's in the universal set, but outside the set B, right? So then B complement should be the set. Let me see. According to this, let me see. It's going to be what? 1, but not 2, not 3. We can do 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, not 16, 17, not 18, 19, and 20. All right. So these are the numbers that are in our universal set S, but outside our set B. All right. So then if we say A intersection B complement, we're basically saying, okay, what's common to both? Right. Let me resize this just to get it on one line. Does it make sense?
Yeah, because I remember doing it, but I just forgot how to put it, like plug it in, I guess.
Oh,
So I get the
how to type it in?
no, like, cause the complement, that little C throws me off. So I just forgot for a moment how to solve for it. So for this one, we'll basically be putting the numbers that both of them share for the first one.
Yeah, like whatever they have in common. Give me a second. I'm just trying to resize it. If that's our B, I'm gonna move this around, and then I'm gonna get a copy of A. Probably just
There's also
Hmm.
I'm gonna just I think I could copy and paste it in the chat, but
Hmm.
this is one of them. The problem looks like this.
Hmm.
That I really don't feel like screenshotting.
Hmm.
um, because I think we use the 3 Venn diagram for.
Get you. Yeah. I'll walk you through that one. Those are a little bit. Let me finish this one, and then we'll look at that one. Might need to shrink it down just a little bit more. No.
And for the second one, we'll do what we did for the first one with the B, and then find the intersection of both of them.
Yeah, I guess if you're comfortable with intersection, then I think you got it. Ugh. Let's go like this, and then I was gonna resize it to make it bigger. All right, about like there is good. Right, and so if we wanted the intersection, we're basically saying what do they have in common? So I'll highlight the ones that they have in common, right? Let me see. 4, 7, 8, 11. They both have 11. They both have 12, 13, 4, and 17, and 20.
They both
Right?
have 7. Well, 4 looks like.
Which one? 1 and 4?
Oh wait, no,
A?
that's 11. Sorry, I didn't. I thought that was 4 from the A.
Yeah. So then when you go to write, wait a minute. Okay, so this asks for the cardinality, right? So what I highlighted are those elements that are common to both. So then the N is asking, oh, well, how many elements are in that set, right? So then it would be what? 1, 2, 3, 4, 5, 6. So the cardinality of that should be 6, right? Because the N is saying how many number of elements are in that set.
Yeah.
That one should be 6. And then it's a similar process for the next one. First, find a complement, and then find where they overlap. But complement just means everything that's in your universal set that's not in your given set.
Yeah. So it'll be 1, 2, 4,
Yep.
and then so forth.
Yep.
Okay.
Okay, so you said you sent another one, right, in the chat?
Yeah, that's the problem. That's how. That's how. I just never really know how to. I really have a hard time with that.
Well, you don't have to claim that. It doesn't have to always be that way. Like it'll change, you know. But don't keep claiming that. If you keep saying you have a hard time with it, then you'll continue to have a hard time with it. You got to change your mind, and then you'll start to notice that it will change. Um, did you sent the other question already? Oh, let's see.
In the chat. Because I think that we used the 3 Venn diagram one.
So you said the 167 said they're like dogs. That whole thing.
Mm-hmm.
Yeah. Let me see. Is it just cats and dogs?
It's saying how many people were surveyed. Because I sent the full thing. You have to probably have to press on it.
No, I see it. I see it. I'm just trying to think of. Okay, so if it's liking cats and liking dogs, I still think I might need the screenshot. And I do screenshots just to make sure, because a lot of times students will like miss something very crucial. Like I need the whole question, so we make sure we're not missing anything. Let's see.
Okay.
Let me see. Can I paste?
I'm about to send this screenshot.
Okay.
Okay, should.
Okay. It says a survey was given. Let's go like this. Oh, this is in the way. There you go. Okay. Let's share here. Okay. Let's see. Let's go. Use this one. Delete. There it is. And then let's rotate and let's crop. Crop. Okay. And we're gonna work here. Here we go. Okay, so it says, let me do one other thing. Crop. Also, what's important with this stuff is to be balanced. Like, study hard, get your work done, but then be sure that you're like eating clean and getting exercise, getting outside and getting fresh air. That's important as well for your sanity's sake. All work and no play, right? Is no good, right?
Yeah.
Okay, a survey was given asking whether people like dogs and or cats. 167 said they like dogs. 187 said they like cats, like both, and said they don't like cats or dogs. How many people were surveyed? Okay, so this looks like a two-circle Venn diagram. I'm trying to think, do we do the Venn diagram, right? Because it's just cats, people that like cats versus people that like dogs, right?
Because I also included like those who don't. Like, I guess that's outside of the.
Well, okay, yeah. So outside is usually, like you said, don't or not, or right? So, like for instance, we'll let this circle. I'll feel. I want none. That looks good. Stroke. That looks good like that. Okay, let's copy and then paste, and that's decent like that, and then. Okay, about like that. Style like this. Okay. So we're doing what? People that like cats versus people that like dogs. So we'll let this left-hand circle be, the left-hand circle be people that like dogs. The right-hand circle will be people that like cats. And we'll let the box be our universal set S, or the number of people surveyed. So inside the dog circle, that needs to add up. So to fill these Venn diagrams in, the recommendation is to work your way, from the inside to the out, right?
Okay.
I can delete this. So so how many people like cats and dogs?
62.
So that means 62 goes into the center region. Okay. So then now as we work backwards, it says 187 said they like cats. So that means inside the cat circle, it needs a total 187.
Okay, so yeah, subtract it. Okay, so.
Right. So what is that? 120, 125?
Mm-hmm.
So 125 is left over. And then inside the dog circle, that needs to total 167. So what is that? 105?
Yeah.
Okay. All right. And then it says 64 said they don't like cats nor like dogs. So that means that 64 usually goes out here. These are people that don't like cats and they don't like dogs. So then how many people were surveyed? You just add all these numbers up. If you tried to add up the numbers that were given, you would actually be counting that 62 twice and it's going to be off.
Yeah,
But
okay. All right.
So if you add these together, you'll get the number of people surveyed.
Okay. I think, let me see before you leave. I think that was basically it, to be honest, because I was having a hard time.
Yeah. So
Those
right. Yes.
The one with the singer, I guess. Like
Best Yeah, best thing is just to screenshot it.
Yes, got it. Sorry.
Yeah, that's a simple thing. That's just the easiest way for me. Just look at a screenshot and then we go from there. What's the command for a screenshot?
I just did the Command Shift 4 thing.
Command Shift 4, okay.
All right.
All right. So what does this say? A survey? Yeah. No, not that one. Where'd it go? Here it is. Last year, singer. Okay. Like this. Okay. Can we shrink? Oh, that's not working for me. Let me do this. This one went from here to here. Share. I want to copy. Can I just paste it here? That would be nice. Paste. Nope. Okay, what if I do it like this? Nope, that didn't do it either. Share. Copy. Yeah, there we go. That's what I want. Nice. Okay. You, my friend, hang out right there. Okay, copy background. There it is, paste. That looks good. Then I want to take this, just cut it, and paste right there. And cool. Actually, yeah, we can expand this. And let's crop. Come on. There's 1 and 2. All right, that's good. All right. So it says last year, singer A performed 3 more than 5 times as many shows during a concert than Team B. The number of singer A concert tours shows exceeded the number of shows by Team B by 27. How many concert shows did each perform? All right, this sounds like an algorithm. We got to think about this one. So singer A, I'm gonna just call it A, performed 3 more than 5 times as many concerts as Team B. 3 more than 5 times. The number of singer A concert tours exceeded the number of shows by Team B. So this is going to be, this equals Team B plus 27. How many concert shows would each perform, right? So we have 2 unknowns, 2 equations we can solve. Every time we have an unknown, we need an equation, right? So they gave us 2 pieces of information, so that way we can solve for the unknowns. I'm assuming I have this set up proper, right? It seemed like it was a direct translation. So then notice the first equation equals A, the second equation also equals A. So then we can just equate these 2 equations together. So we can say B plus 27 should equal 3 plus 5B. All right, now at this point we have 1 equation, 1 unknown, so we should be able to solve. All right. So if we want to solve for B, how would you solve for B from here?
Wait, let me think. Okay, so because I didn't catch the first 2.
Let's back up. So it says last year singer A performed 3 more than 5 times. Let me kind of go like this. It's kind of like so I can see it. Let me just move all this down. Okay, so it says last year singer A performed 3 more than 5 times. Again, 3 more than 5 times team B. Right? It was kind of like a direct translation.
Okay.
The number a concert tour shows, so their shows exceeds the number show of team B shows by 27. So it's basically the number of shows of team B plus 27. So then that's what they gave us. So we had two unknowns. We're trying to solve for A and B, and we had two equations. Every time we have an unknown, we need an equation. So we have two equations. So then the first equation equals A. The second equation equals A. So then that means we can say this equals this.
Mm-hmm.
Right. So then if we solve for B from there, what would you do? How would we solve for B on this line?
So I want to say, is it kind of the same direction with the y equals mx plus b?
Okay. What would you do if it was y equals mx plus b?
We'll be subtracting
Mm-hmm.
27.
You can do that, right? So you can subtract, let me see. You can subtract the 27. Okay, suppose you subtract the 27. Then what?
Do the same thing on the other side.
Okay.
And then that'll be, hold on. Gotta get my calc. Okay. It'll be a negative number, but that's not gonna matter right now. So 24 plus b. Now we add 24, and I guess no, wait, hold on.
Okay.
Because we have b on both sides.
So how could you get those b's on one side?
Because it's multiplying.
Okay. So
1b.
yeah, right. So what you did was nothing wrong with it. So then let's see here. Let's move the 24 back to the left. So the inverse operation of negative 24, we're just going to move it back to the other side using the inverse operation. Okay. So then this will give us b plus 24 equals 5b. So the first recommendation is to isolate your variable, get the variable by itself. So any term that has b, we want to get it on one side. So the same way we move that 27, we can actually move one of the b's, right? So to me, it looks like this left-hand b is easier to move. If we subtract b on both sides, that's like subtracting 1b.
Yeah,
Okay.
that's why I said 1b earlier.
So then 5b minus 1b ends up being 4b, right? So now we can use the inverse operation. If we're trying to get the b by itself,
We just divide, and then that'll be
yeah, divide both sides by 4, and then b equals 6. Okay. So then if that's the number of shows of team B, now we can use that to go find the number of shows of team A. It seems like it's easier to just plug it into that second equation.
okay.
6 plus 27, is that 33?
Yeah.
Does that make sense? So then the only other thing is we do want to confirm that these numbers work in both equations. So for instance, if we plug 6 into equation 1 and we plug 6 into equation 2 for B, it should make both of them, they should both equal 33. So notice that 6 times 5 is 30, plus 3 gives us 33. And then also 6 plus 27 also gives us 33. So provided that we set it up the initial part correctly, then we can be confident in everything beyond that.
Okay.
Mm-hmm.
I think I got it, because I think on the other assignments where it was like a question like this, I did not answer. Because I was like,
Okay.
so I could probably
Yeah.
try to go back and do it.
So like with with late assignments, well, I think I removed the late penalty for chapters 1 through 3, right? So I mean, honestly, you can recover a lot of points there. Generally speaking, for my classes, I forget the grading rationale here, but generally speaking, if you're going back and like doing old assignments to recover points, I usually encourage the students to prioritize the exam. So, but I don't think that, I think we've only had the one exam, and so that's not due until next week. That's my impression.
Yeah, I've already completed all the other assignments for the last week
Yes,
and for in the first week. So I don't really have to go back and do anything unless like I want to. But
right.
I'm pretty
Okay.
up.
Yeah. All right. So what I'll do, let me go ahead and make a copy of all of these notes. I'm just gonna make a copy available. I want to share, send it to Box. Let's put it in the right folder. This is the fall at Morris Brown. Notes updated daily. And oh, I forgot to do that. Let me load one thing before this, and then I'll come back and load this right now. Were there anybody have any other questions before we part? Okay. All right, ladies and gentlemen. So, like, if there aren't any other burning questions, we're actually going to go ahead and end the session here. From one beautiful mind to another, enjoy the rest of your evening or the rest of your day, and we'll meet Thursday, same time, same place. Take care. You take care, guys. Peace.
All right.
Mhm. I think I'm missing this one. Let me share, send it to Box. Fall, Morris Brown, notes, updated daily. Yeah, this should be 16, send to Box. And then I'm going to share this one. Send. Okay. So again, when this bar finishes loading, you should be able to access a copy of all of these notes, everything that I write. I put a link in Box. I mean, in the discussion, like the first class, and so that link should work. It's a Box link to access these. All right, gentlemen, ladies and gentlemen, take care. See you next time. Okay.